Alright, so we're going to be looking at the first principles function. Now, first principles is fun, because look at that. Now, there's a fair few things on there. You need to break it apart so that you fully understand it. That way you know what's going on. First of all, you have the first bit here. Thank you. First of all, you have this bit on the top here. Now you have f of x plus h minus f of x. That comes from what we were doing on Friday. We're looking at the difference between the two y values. So this is still finding the gradient, in other words. And then remember the bottom always reduced to a h because you have x plus h minus x as your difference between the x values on the bottom. So that reduces to just a h. Any questions with that? So this is still doing the gradient, but we're using that other notation. It'll become clear as to why we need to do it that way in a second. Then we have to take the limit. Now when you take the limit, remember you can just make it equal to 0 unless you need to divide first. In which case, if you have a look on the bottom here, we can't just divide it by 0, correct? So we have to do some divisions first to cancel it so that we don't have a 0. In other words, all of your terms on the top should have a h. Any questions? It looks really confusing. It's okay, it's not that bad. It's just annoying to do more than anything. So if you're not sure, I'll break it down into these steps. Number 1, find f of x plus h. Number 2, do f of x plus h minus f of x. Number 3, you can kind of see where I'm going with this. F of x plus h minus f of x. Then divide it by h first. Once you've found that, then take the limit. I'll do it once where I do it all in one go, and I'll do it once where I break it apart so that you know what's going on. That way you will see why this looks like a lot of steps, but it's actually simpler to go with. Okay? So, consider the function for which f of x is equal to x squared minus 5x plus 4. So the first bit, which is part A, is telling you to use first principles. Now one thing I forgot to mention is when you're doing first principles, you're finding the gradient at any point, which is why you need it as f dash of x. Now, I did forget to mention one more thing. F dash of x is the same as dy dx, which, if you remember, we were using this notation before. They're both the same, okay? So if you ever see f dash of x or dy dx, you are finding the difference. You're finding the rate of change, okay? Right, back to this. So I'll write out the full one. So f dash of x is equal to the limit as h goes towards 0. F of x plus h minus f of x over h. Do you want me to break it in steps first so you can actually clearly see what's going on? Yes, okay. I'll do it. Number 1, we need to find f of x plus h. What does that mean? What does that mean that we're doing? Instead of x, we're going to put in x plus h, that's it. So wherever you see an x, for example x squared, you'll put x plus h. Do not forget the brackets, it's the most common mistake that people make. Then minus 5 bracket x plus h plus 4. Once you've done that, expand it. And yes, it does give you a messy expression. So that's x squared plus 2hx plus h squared minus 5x minus 5h plus 4 then group anything you have that's common together. So you have the x squared. I'll group all the x terms first. So you have 2hx and also the minus 5x. Plus h squared minus 5h plus 4. Yes, you do get a giant expression every time. 2. We're going to now subtract it with f of x. So you have all of that above. I'm not going to write it again for now. You can see it's above anyway. Minus x squared minus 5x plus 4 in brackets. I'm going to expand that first before we do anything. Alright, if we're subtracting stuff, I made a mistake. If we're subtracting stuff, then make sure you just match the terms. X squared minus x squared, they cancel. 5x, there's a minus 5x, they cancel. Then you have a minus 4 and a plus 4. Now, here's the point where you double check what you're doing. Whoops, subtracted the wrong one, didn't I? Here's the point where you double check whether or not you're doing the right thing. When you get to that line, they should all have h's in it, because you're going to be dividing by h. Yeah? So remember right here, we're going to have to divide by h. So make sure by the time you get to that line, you're left with all h's. Alright, part 3. You would do this expression divided by h. So f of x plus h minus f of x over h, which is 2hx plus h squared minus 5h, giving you 2x. I jumped ahead. 2x plus h minus 5. And then the last bit, you just take the limit as h goes to 0. When I take the limit as h goes to 0 for this part, what do I just put in? 0. So what am I left with? Okay. Now, what that means is, so I'm going to skip the, no, we'll do it. What that means is, if I want to find the gradient at any point, I can now, using that function. So, see part B, hence obtaining the gradient of a graph of a function at a point 1, 0. You would then put in f dash of 1. What does that mean? Yep, you substitute 1 into x. So that's 2 minus 5, which is negative 3. Okay, nice and simple from here on. The hardest bit is to get this first function. And then part C, when x is equal to 4, you would do the same thing. Now, I should probably note, this is an instantaneous rate of change, which means it's actually, you know how I said before, we couldn't technically find the instantaneous rate of change? Using this, we now can. Does that make sense? Okay. Would you like to see the x to the power 4 one? Yes. Would you? Really? Oh, okay. Alright, this time I'm going to do it just by writing out the whole thing. I'm not going to break it apart, just so that you guys can see why it's really messy. And I'm going to have to start writing really small, because I won't be able to fit it on the screen otherwise. Alright, here we go. So f of x plus h, we're going to put 3x plus h minus 2x plus h to the power 4, oh god, minus, in brackets, don't forget the brackets for the last one, 3x minus 2x to the power 4, all over h. Now, anyone remember what's the rule for figuring out higher powers? Pascal's triangle, what's the next one? What's the next one? Yep. We'll leave that for now. So x power 4, x power 3, x power 2, x, and then h power 4, h power 3, h power 2, h. Okay. Now, don't forget, you can actually just, does anyone remember all the power stuff or not? Remember how I did this? Going from highest powers to lowest from one side and then taking the other term, which is a h, going from the highest power all the way down to the lowest power. Yeah? Okay. So then we have 3x plus 3h minus 2x over 4 minus 8x cubed h minus 12x squared h squared minus 8xh cubed minus 2h over 4 minus 3x plus 2x over 4. All divided by h. You see why I'm telling you to break it down into 2 lines if you need to. Alright. Now, look for all the x terms, make sure that they all cancel. I'm hoping I haven't done anything wrong. And then 2x to the power 4. Then you're left with 3h minus 8x cubed h minus 12x squared h squared minus 8x h cubed minus 2h over 4 I'm going to divide it, so we're left with 3 minus 8x squared 8x cubed minus 12x squared h minus 8x h squared minus 2h cubed. Then when I take the limit being 0, you're left with 3 minus 8x cubed. There we go. Done. Anyone have a headache now? Is that all kind of straightforward with the process? Because that's all it is. You just have to make sure that when you're doing it, you're being really careful with the terms and more being careful with not making a mistake. Alright, so while I'm at it, if you go on main, I'll clear this first so it doesn't look silly. If you go on main, there's, and then you go on keyboard here. Now, you have to remember the notation we're going for. Remember it's dy dx. For this one, what you would do is you will write down whatever variable you're differentiating to on the bottom. In other words, just write down x on the bottom for now. Don't stress too much about what it is. And then whatever expression you want to differentiate, you put it inside that bracket. So the one before, x squared minus 5x plus 4, there it is. Okay? Don't worry, but by the time we get to the next lesson, you'll be able to learn how to do it that quickly as well. Yes, you will.